So I've been able to calculate the mean and standard deviation for all of the players on the team. I cheated a little and used my calculator. I've done all of these long calculations by hand, I promise, but in the interest of actually getting this video posted in time for you to work with it, I cheated and used my calculator. I'll show you how to use your calculator too, but hopefully doing it longhand, you got numbers like these. Now, in kind of full disclosure here, sometimes what happens is our calculators kind of do this a little bit differently, and I'm not sure why, but sometimes we get slightly different numbers. Mean, you should not get a different number than these ones here, but sometimes we get slightly different decimal places for our standard deviation. So if your standard deviation is wildly different than these numbers, go back and see if there's any any steps that you missed. But if your numbers are just slightly different than these ones, it just might be that my calculator did something a little bit differently than what you did, or maybe it kept certain decimal places. I'm not sure exactly why that happens, but as long as we're all in the same ballpark, that's really what I care about, because what we want to do is we want to look at what these numbers mean. Okay, so we've got all of the girls' mean. What are we measuring here? Scores tied. This is, I don't know, these are just stats. Okay, so field goal percent. Okay, so these are field goal percent. So we've got these means, so we've got our average field goal percents, and we're looking at our standard deviation. So if we look at the means, it looks like Paige is like, she has the lowest field goal percent. So she might be a really, based on mean, she might be a really less than good pick to go up and make the foul shot for the end of the game. Okay? And it looks like Star, well, no, actually Anna has the highest field goal percent. So she looks like she'd be a really good candidate for this substitution. But if we go that one step further and look at our standard deviation, we can see that Paige, even though she has the lowest mean, she also has the lowest standard deviation. And what that means is Paige's shots are most consistently around that average. Okay, Morgan, if we look at Morgan has a pretty fair average, right? But her standard deviation is very high compared to the other girls on the team. And this means that she is the least consistent player on the team. And if we go back and we look through all this data, yeah, she has like the lowest lows and some of the highest highs. So she has some pretty bad games and she has some really good games. And so this gives her that really large standard deviation. If we look at Paige, though, that has this very low standard deviation, look at Paige's numbers. Paige always is 33, 34, or 35% consistently, right? So that's why her average is consistently really close to 34%. So Paige is the most consistent player on the team, and Morgan is the least consistent player on the team. So even though Morgan has these potential to do really, really, really well, Morgan has these really high percentages some games. She also has the chance of doing really, really, really poorly, right, compared to everyone else on the team. So that's how standard deviation can help us make decisions, right? It tells us how consistent these players are. So if we go back and look at these questions, I filled in this table here with the same numbers that we had on the last table. If we compare the the lowest standard deviation, well, Paige had the lowest standard deviation, right? We're just going to use sigma because we have a symbol for that. Which player has the, what does this imply about her shooting consistency? This means she is the most consistent player. Okay? So based on past performance, which player has the potential to shoot the most poorly? Well, Morgan has the potential to shoot the most poorly, but she also has the potential to shoot the most successfully, right? Because she's got those really low scores on some games and some really high percentages on some other games. So Morgan kind of is at least consistent, right? And this is just kind of speaking to this idea of consistency. Standard deviation tells us how consistent our data is, which can be a really, really, really good measure, right? And sometimes we want we want a team of basketball players that have a wide variety of heights. That's what we're looking for. Maybe we're looking for that huge range of data. So just because something is consistent doesn't necessarily mean it's bad, right? That's not up for us to decide. We're just doing the math behind it. We're just getting the numbers, and then afterwards you can make decisions on it. So consistent doesn't always necessarily mean good. It just means consistent, okay? If you are consistently bad at something, that's great. You're going to have a low standard deviation, but you're not that great at it. So maybe that's not such a good measurement, okay? So again, I don't want you to think that this is good or bad. It's just a measure of consistency. All right. I hope that makes sense. I hope you managed to survive doing all those long calculations. It's not terrible, but I'll show you in the next video. I'll show you how you can use your calculator to be able to get there faster. All right. Thanks.